Now, for our second lesson, we're going to look at some very special cases. Most of these questions look identical to what we did before, with one slight twist. So we're going to try and find the zeros for this so we can graph this. So two numbers that times to make 5 and add to make 4, well, that's going to be pretty difficult, so we might have to think of something else for this. So we're trying to solve this. Now, if you try and work out the discriminant, which is b squared minus 4ac, 16 minus 4 times 1 times 5, you get negative 4. So if your negative discriminant means that there's no real solutions to this problem. So you can either use the quadratic formula for this or completing the square. But you'll end up with a negative square root, so no solution. So what that means is it never crosses the x-axis. But obviously we can actually draw this graph. We know it's got a y-intercept of 5. We know it's a nice U shape. And if I actually use my graph here, let's take a look at what it looks like. And there you can see now, it never actually crosses the x-axis at all. We can still answer this question though. When is this greater than 0? When is it above the x-axis? Well, actually it's always above the x-axis from that picture here. So we can actually make the conclusion that it's all real numbers. So just a special case for that type of problem. Now there are similar ones as well, so let's look at a slight change. If I make it less than 0, then same thing, when we try and solve this, we still get no solution. And now look at the graph. When we're looking for less than 0, we're looking when is it below the x-axis. So actually for that one, never. It's never below the x-axis, so the answer to that question is no solution. Slightly more tricky is if I put greater than or equal to. So same thing as we did before, find our roots, we can draw the graph again. Oops, a little bit too much revealed on this one. So if I try and solve this one actually factors perfectly, x plus 2, x minus 2. X plus 2, x plus 2. So it means our roots are both negative 2. So when I come to graph this one, what I actually get is this. So when is it greater than or equal to 0? Well, when is it above the axis or equal to the axis? Actually, every single point on that question. So that one should also be all real numbers. Same question this time, but just greater than 0. So greater than 0 means when is it above the axis, but we can't include the axis. Well, actually, it's above the axis at every point with one exception. When it's at negative 2, the y value at that point is 0. So I can't include 0. So every real number except for 0, or a good way of saying that is just simply x does not equal, I'm supposed to say negative 2. If I change it just a slight bit, this time make it less than or equal to 0. So when is it below the axis or equal to the axis? Well, actually just 1 point this time. Basically where the vertex is. So my answer for that one would just be simply x equals negative 2. And our last possible case we could have for this one is, what if it's strictly less than 0? So less than 0 means when is it below the axis? And actually it's never below the axis for this one. It touches at negative 2, so for that one, no solution. So just be very careful when you have those special cases. They can be a little more complicated to work out, and they tend to occur when either the graph doesn't touch the axis, so there's no real solutions, or when the graph touches at just 1 point and you get what's called that repeated root.